Hello, science fans. Welcome back to another exciting journey into the world of cutting-edge science and technology. Today, let's talk about thorium, an element that could revolutionize how we power our world. Imagine a future where our cities shine bright, powered by a source that's both clean and nearly limitless. Thorium is a heavy, silvery metal found in the Earth's crust, named after Thor, the Norse god of thunder. It's more common than you might think. There's actually more thorium in the ground than uranium, making it a surprisingly abundant resource. Unlike uranium, thorium can't start a nuclear chain reaction on its own, but with a little help from a neutron source, it transforms into a powerful nuclear fuel. This unique property makes thorium both intriguing and promising for the future of energy. Why does this matter? Our planet needs clean, reliable energy. The demand for electricity is growing every year, and we need solutions that can keep up without harming the environment. Fossil fuels are warming our planet, and renewables like solar and wind depend on the weather. Sometimes the sun doesn't shine or the wind doesn't blow, making it hard to rely on them alone. Thorium offers a new kind of nuclear energy, safer, cleaner, and more abundant. It produces far less radioactive waste than traditional uranium reactors, and the waste it does create is less dangerous and decays much faster. For decades, uranium dominated nuclear power, but now scientists are taking a fresh look at thorium. They're exploring new reactor designs that could unlock thorium's full potential and change the way we think about nuclear energy. It could unlock a future of abundant clean energy for everyone. Imagine every home, school, and hospital powered by a source that's both safe and sustainable. This isn't science fiction. Thorium's potential is grounded in real physics and chemistry. Researchers around the world are already testing thorium reactors and making exciting discoveries. The journey to understand thorium is a story of innovation and hope. It's about scientists and engineers working together to solve some of humanity's biggest challenges. We'll explore how thorium works, how it can generate electricity, and why it's considered safer and cleaner than what we use now. We'll also look at the challenges ahead and what it will take to make thorium a reality. Imagine a future where the lights stay on without polluting our planet. Clean, affordable energy could be available to everyone, everywhere. Thorium could be the key to that future. It's a chance to rethink how we power our lives and protect our planet for generations to come. So let's dive into the world of thorium and see what makes it so special. Get ready to learn about the science, the technology, and the people behind this incredible element. Get ready to discover a new energy hero. Thorium might just be the breakthrough we've been waiting for. The story of thorium is just beginning. There's still much to learn, and the adventure is only getting started. Let's see how it could change everything. The possibilities are as vast as our imagination. Welcome to the age of thorium. The future of energy might be closer than you think. How do we turn thorium into electricity? It's a fascinating process that combines advanced science with innovative engineering, and it all starts with a special kind of nuclear reactor. The key player here is the liquid fluoride thorium reactor, or LFTR, a next-generation reactor designed to unlock thorium's energy potential. Thorium itself can't start a nuclear chain reaction on its own. It needs a little help. Think of it like a campfire that needs a spark. That spark comes from neutrons, often supplied by a small amount of uranium or another fissile material. When thorium-232 absorbs a neutron, it undergoes a transformation, becoming uranium-233. This new element is special because it's fissile. It can split apart when hit by another neutron, releasing a burst of energy. This splitting, called nuclear fission, not only releases a tremendous amount of heat, but also more neutrons, which go on to trigger more reactions. This creates a self-sustaining cycle, producing continuous energy. What's remarkable is that the reactor breeds its own fuel as it operates, making it incredibly efficient and reducing the need for constant refueling. The heat generated from fission is transferred to molten salt, which acts as both a coolant and a carrier for the nuclear fuel. This molten salt gets extremely hot, efficiently capturing the energy produced. The hot molten salt is then used to boil water, creating high-pressure steam. This steam spins a turbine, which is connected to a generator, ultimately producing electricity for our homes and cities. In the end, a thorium reactor is a high-tech, clean way to boil water and generate power, without the pollution of traditional fossil fuels. There's no burning of coal or gas and no carbon emissions, just the clean, efficient power of the atom at work. The process is continuous, reliable, and highly efficient, providing a steady flow of electricity. Thorium reactors could deliver a constant, dependable source of energy, keeping the lights on day and night regardless of weather or time. It's a beautiful cycle, clean, safe and sustainable, offering a vision of a future where energy is both abundant and environmentally friendly. That's how thorium can power our world, providing the energy we need while protecting the planet we love. The future of electricity could be molten, not solid, revolutionizing the way we think about power generation. And it all starts with thorium, a humble element with the potential to change everything. When most people think of nuclear power, the first thing that comes to mind is uranium. For decades, uranium has been the backbone of nuclear energy, powering cities and industries around the world. But there's another element quietly waiting in the wings: thorium. Thorium is a game changer, offering a fresh perspective on how we generate clean, reliable energy. Traditional reactors rely on solid uranium rods. These rods can overheat if not carefully managed, leading to potential safety risks and even catastrophic meltdowns. Thorium reactors, on the other hand, use liquid fuel, thorium dissolved in molten salt. This innovative approach is inherently much safer, as the liquid fuel can be drained in emergencies, stopping the reaction instantly. Uranium fuel requires expensive and complex enrichment processes before it can be used. Thorium, however, can be used almost directly after a simple start, making it more accessible and cost-effective. Nearly all of the thorium that's mined can be converted into fuel, maximizing resources. In contrast, most uranium ore is left unused, resulting in significant waste and inefficiency. Thorium reactors also produce far less radioactive waste than their uranium counterparts, reducing the burden on future generations. Uranium reactors generate long-lived waste and dangerous plutonium, which poses security risks and can be used for nuclear weapons. Thorium's waste, by comparison, is much shorter-lived and doesn't create plutonium, making it a safer choice for the world. The uranium-233 produced from thorium is difficult to weaponize thanks to contamination with other isotopes, adding another layer of security. Thorium is not only more efficient and less wasteful, but it also offers greater security and peace of mind for communities. It's a cleaner, safer alternative to uranium, with the potential to revolutionize how we think about nuclear energy. The difference is clear. Thorium could be the future of nuclear energy, lighting up cities with less risk and more sustainability. Less waste, less risk, and more power for the world's growing needs. That's the promise of thorium, a new era of energy that's within our reach. The nuclear game is changing, as technology and innovation open new doors, and thorium is ready to lead us into a cleaner, safer, and more powerful future. Safety is the top concern with nuclear power, but thorium reactors are designed to be meltdown-proof. LFTRs use liquid fuel at normal pressure, unlike traditional reactors that operate under high pressure. No high-pressure water means no risk of explosive steam accidents. The real genius is the passive safety system, a freeze plug at the bottom of the reactor. If the reactor overheats or loses power, the plug melts, and the liquid fuel drains safely into a holding tank. No computers or human intervention needed. The reactor shuts itself down. As the fuel heats up, it expands, slowing the reaction automatically. If it cools, the reaction speeds up, a natural balance. This self-regulating design makes meltdowns virtually impossible. Low pressure, passive safety, and self-regulation set thorium reactors apart. They're built to fail safely, not catastrophically. The result? A fundamentally safer nuclear power. Thorium reactors could change public perception of nuclear energy. Safety isn't an afterthought, it's built in. That's the future of nuclear power. Nuclear waste is a huge issue, but thorium changes the game. Thorium reactors produce far less waste than uranium reactors, hundreds of times less. The waste is also much less dangerous, becoming safe in just 300 to 500 years instead of hundreds of thousands. This makes storage and management much more practical. Thorium reactors can even help clean up old nuclear waste by burning long-lived elements from spent uranium fuel. They act like waste incinerators, shrinking the problem and generating more clean energy. Thorium isn't just a solution for the future, it can help fix the past. Less waste, safer waste, and even waste reduction. That's the thorium advantage. Is there enough thorium to power the world? Absolutely. Thorium is 3 to 4 times more abundant than uranium and found all over the globe. Countries like Australia, India, Norway, and the US have huge reserves, often as a byproduct of other mining. A single ton of thorium can produce as much energy as millions of tons of coal. Known reserves could power humanity for centuries. Thorium's abundance means energy security for many nations. It's a resource that could lift countries out of poverty and reduce global tensions. Thorium is the fuel for a sustainable, peaceful future. If thorium is so great, why aren't we using it? History. The Cold War pushed uranium reactors because they produce plutonium for bombs. Decades of investment, infrastructure, and regulations are built around uranium. Switching to thorium means new reactors, new materials, and retraining engineers. Technical challenges remain, like handling corrosive molten salt and removing fission products. Public perception and regulatory hurdles are big obstacles. Changing the system takes time, money, and political will. But the science is sound, and the potential is huge. The main barrier is commitment to change. The good news? We're not starting from scratch. Oak Ridge National Lab ran a molten salt reactor in the 1960s, proving the concept works. Today, countries like China and India are building new prototypes. We need funding, modern test reactors, and real-world data to move forward. Governments and private companies must work together to accelerate progress. Public education is key. People need to understand thorium's safety and benefits. The transition will be gradual, starting with small modular reactors for remote sites or waste cleanup. As the technology matures, larger plants can replace coal and gas. Step by step, we can build a thorium-powered grid. The future is within reach if we invest and innovate. We're at a crossroads. Climate change demands bold solutions. Thorium offers clean, abundant, reliable energy for generations. Imagine cities powered with almost no carbon emissions, clean air, and affordable energy for all. No more dependence on volatile fossil fuels, just stable, peaceful progress. Thorium's waste is manageable, and its benefits are enormous. The journey requires investment, vision, and public support. Scientists and engineers are ready. The technology is within reach. The story of thorium is about potential. Our potential to solve big problems. The next energy revolution could be powered by thorium. Let's seize the opportunity. A cleaner, brighter future is possible. And it starts with thorium.